right, folks, Mr. Hill again. I wanted to show you some things in this video about the activity series. Okay, the activity series lets us make predictions about what kinds of chemical reactions will happen and which ones will not. So in order to do the reactions or look at the reactions I'm going to show you in this video, you should have an activity series handy. You will also need it to answer the questions on the study guide, and you'll be able to use it on the quiz that we're going to have on Chapter 8 at some point after spring break. Okay, so just real quick to show you what this would look like if we had one in front of us, which hopefully you do because you went to page 272 in a textbook, or honestly, even if you just Googled metal activity series, you would find one of these. But this is what the activity series looks like. Okay, we have elements from lithium through gold listed from most to least active. The most active metals are at the top, the least active metals are at the bottom. So the first idea is that a more active metal, like lithium, will replace a less active metal, like magnesium. Okay, as long as it's below it, it will replace it in a compound by single displacement reaction. Same's true for halogens. Halogens will replace each other, where a more active halogen like fluorine would replace a less active halogen like chlorine. It'll also tell us about reactions with water, acids, or oxygen. Okay, some things will react with all of those things, including cold water. Other things will react with none of those things. Okay, so basically the way it's going to look on your test and the way it's given to you on your study guide is that I give you a pair of substances. Okay, and we have to predict whether or not a reaction will occur, and then we have to write the products of the reaction. Okay, so the first type of thing that can happen is that a metal can react with a compound that contains a metal. Okay, what we're going to do in this case, because we have a metal and a compound with a metal, is we're going to compare the two metals. Okay, so you'll find them on the activity series and see which one is higher up on the list. Okay, according to the activity series, sodium is slightly less active. It's just below calcium, which is more active. So the less active metal cannot replace the more active metal in the compound. Okay, so a reaction that does not happen, all we have to write is no reaction. Okay? Oh, I'm sorry. I had you zoomed in. Okay, so sodium is less active than calcium, so it will not replace the calcium in this compound, so we write no reaction. Okay, if the opposite is true, if we see an element like magnesium and a compound that contains a different metal, like aluminum chloride, okay, here again we have a metal and we have a different metal that's in a compound. We got to compare their activity using the activity series. Magnesium is more active, aluminum is less active, so that means that the more active metal will replace the less active metal in the compound. So magnesium switches with aluminum. Okay, so here we're going to have aluminum by itself, and we're also going to have the combination of magnesium and whatever the other element was combined with. Okay, magnesium plus chlorine. We got to write the formula for that compound. Okay, if we think back to ionic compounds, magnesium, which is in group 2 on the periodic table, would have a +2 charge. Chlorine, which is in group 17 on the periodic table, would have a -1 charge. So we need 2 of the chlorine to make a neutral ionic compound. Okay. The other thing I would ask you to do in this section is that for those reactions that occurred, to balance them. Okay, so now that we have this, we would want to balance this reaction. Okay, I showed you in my first video on balancing that if we see something odd on one side and even on the other side, I should make the odd number even by putting a 2. And now I have 6 chlorines, so I'll go over here and put a 3 to give me 6 chlorines. And now I have 3 magnesium, so 3 here, and then 2 aluminum there. Okay, so that's the first two things. You'll have to compare two metals and see if they will react. Okay, the other type of reaction, or the next type of reaction, involves water. So very active metals like sodium or potassium will react with water. And they'll do it whether it's cold or warm. Some things will react with water, but only if it is like water vapor or steam. So we could write a G here for water vapor, or we could put an L here for liquid water. That'd be like cold water. If it will react with water that is liquid, it'll also react as steam though. Okay, so this reaction, according to the activity series, if we find sodium, in the box next to it, it says react with cold water. So we're gonna put the products of the reaction then, if this is a reaction that happens. Okay, when things react with cold water, they will replace one of these hydrogen atoms. So if we take a hydrogen away from water, what's left? OH. So this is H2O. We take one of these away and we have an O and an H. That's hydroxide. Okay, hydroxide is a polyatomic ion with a -1 charge. So I need to put the formula for sodium hydroxide. Sodium in group 1 has a +1 charge. Hydroxide, which has a -1 charge, has the formula NaOH. Okay, we also need to do something with that hydrogen that we took away from water here. Hydrogen is a diatomic element, so if we need hydrogen by itself, it is always combined in the form of H2. If you need to write hydrogen as an element, it's always H2. Okay, again, this reaction would not be balanced. So if I put a 2 here, a 2 here, and a 2 here, it would be. Okay, if something is lower down on the periodic table, like say nickel, nickel does not react with water, so we would write no reaction. Okay, the next type of reaction involves metals with acids. So for example, we could have an acid like HCl. This is hydrochloric acid. You should know this one as well as this one. Those are the two examples of acids that I want you to know for now. Okay, so a very reactive metal like magnesium will react with an acid. Okay, when they do, we will replace the hydrogen, and in this case, we replace all of the hydrogen. Okay, so I'm going to take the hydrogen away from this, so I would get H2. And I'm going to put magnesium and chlorine together. Again, magnesium has a +1 charge, or excuse me, magnesium has a +2 charge, chlorine has a -1 charge, so to make a neutral compound, the formula is MgCl2. Okay, again, I need to balance this, so I'd put a 2 here, a 2 there, and a 2 there. Okay, a very unreactive metal like copper will not react with this sulfuric acid. If it would say on the activity series next to copper that it reacts with acids. Here it does not say that, so we would put no reaction. Okay, and then the last type of reaction involves oxygen. Okay, most things will react with oxygen. For instance, aluminum will react with oxygen. Okay, we know that because if we look up aluminum on the activity series, next to it, it will say reacts with oxygen. Okay, so if it does happen, we need to write the oxide product. Okay, aluminum has a +3 charge. It's in group 13 on the periodic table. Oxygen has a -2 charge. So to make a neutral compound, I need to have this formula, Al2O3. Okay, again, we need to balance this. There's 3 oxygens here and 2 oxygens there. So if I put a 2 here, there would be 6 oxygens. Put a 3 there, that's 6 oxygens. And now I have 2 times 2 is 4 aluminum, so that would make it balanced. A very unreactive metal, like say gold. Okay, we look up gold on the activity series. It says fairly unreactive forming oxides only indirectly, okay? The only thing that you need to know about that is that it does not react with oxygen like this, okay? So if it is the last three elements, silver, gold, or platinum, and they're trying to react with oxygen, with acids, or with water, they don't do it. You're going to put no reaction for that one too. Okay? So I hope that this helps you. Oh, there's one more. I'm sorry. There's one more type of reaction, and it involves halogens. So for instance, a halogen like iodine, okay, if we combine this with a compound that contains a halogen, okay, we can compare these halogens like we compared metals and use the activity series of halogens to see if the reaction would happen. Okay, iodine, way on the bottom of the list. This is less reactive than chlorine. Okay, if the element that's by itself is less reactive than this, that's in the compound, we do not see a reaction. And then if the reverse were true, where we had a very reactive halogen with some less active, so this is less active than fluorine, then fluorine will replace chlorine in this compound, and we'll get chlorine by itself. Chlorine is another element that is diatomic. If you want to write the element chlorine, you always put Cl2. That's true for all the halogens: chlorine, iodine, fluorine, bromine, and so on. Okay, the other product of this is the combination of sodium and fluorine. Okay, remember, sodium has a +1 charge from group 1. Fluorine in group 17 has a -1 charge, so the formula is NaF. Again, to balance this, I would need to have 2 fluorines on this side, and that means I would need to have 2 sodium, and that gives me the 2 chlorine I was looking for. Okay, those are the types of reactions that you will see and have to be able to make predictions about using that activity series, again, on page 272 of your textbook. So I hope that this has helped you. If you have any questions at all, please don't hesitate to ask me. And if I don't hear from you, have a great spring break. Thank you.